Here we have a typical problem that requires the use of the point-slope formula. It says find the equation of a line containing the point 2, 5 with a slope of 3/5. Then it goes on to say express the answer in in slope-intercept form. I have to learn how to read. Alright, so let's collect our data. What do we have for data? Well, we have a point x1, y1, and that's 2, 5. This guy right here. And we have a slope, that's m, which is 3/5. Now we have to dig into our deep reservoir of mathematical knowledge, which could be on a cheat sheet, could be in your memory. Hopefully it's in your memory. And we pull out the point slope formula, which looks like this. Y minus y sub 1 equals m times x minus x sub 1. Now it's plug and chug time. Alright, y is y. Right, that's the coordinate for the point that can be anywhere on the line. y1, well, we're given y1 to be 5. So I plug that in there. Slope, well, that's this guy over here. So that's 3/5. X, again, remember, is the coordinate for the point that can be any point on the line. And x sub 1 is the given point, is the coordinate for the given point, and that's x sub 1 equals 2. And if you stopped here, you'd be wrong, because we have to give our answer in the slope-intercept form, which means we now have to dip again into our vast repertoire of mathematical knowledge and retrieve the point-slope-intercept form. Looks like this. Clearly, this does not look like that. Let's first start by distributing this 3/5 so we can get rid of the parentheses. Always a good idea to start any equation by getting rid of parentheses. That's why it's PEMDAS. Remember PEMDAS? Right? First thing, get rid of parentheses. Anyway, I digress. 3/5 times x is, what a surprise, it's 3/5 times x. 3/5 times minus 2, well, that's plus 3/5 times minus 2. Okay, now it's time to do a little chugging. 3/5 times x is still 3/5 times x. Let's put a 1 here just to keep things simple. 2, 3, and now we multiply fractions. We multiply numerators times numerators and denominators times denominators. 3 times minus 2 is minus 6. 5 times 1, both of them plus, are going to be 5. Almost wrote down a 1 there. That would have been wrong. Can I simplify that? No. So I have y minus 5. Is that in the right form? No. Can only have a y on the side, on the left side, and it's got minus 5. So I have to add 5 to both sides. Oops, I have to add a fraction. I have to add 5 to both sides. Okay, well, now I have to deal with this. So I have 6. Well, this is easy over here first. Let me do the easy part first. I always like to do easy stuff first. And this is not going to change. Still going to be 3/5 x. Now I have minus 6/5 plus 5. Well, alright, I cannot add them or subtract them unless they have the same denominator. The denominator is 5, so I'm going to multiply the denominator times 5 and the numerator times 5. That's going to leave me with the denominator of 5, so I can then add them. And so I proceed. Minus 6 over 5, 5 times 5 is 25. 1 times 1 is 5. Aha! I have the same denominator, so I can add these together. Minus 6 plus 25. When I add the numerators, gives me 19, and the denominator remains unchanged. And that's a plus. It's implicit, so it's 19/5. I cannot simplify that anymore, and that does in fact look like the point slope form of the equation. So that's my answer. Y equals 3/5 x plus 19/5, and that gives me the extra added bonus of knowing that the slope of this line is 3/5, and the y-intercept falls on the y-axis at the number 19/5. Not bad. All right, if you followed that, if you understood it, now is a good time to sort of test to see that you can do this on your own. And I would strongly recommend you do example 3 in the book on page 246, or just copy this from the video. Till next time, I'm Luke Kane. Thanks for watching. Bye now.